This is block 6 of topic 3. In this lesson, we're going to be able to use a matrix representation of polygons and their transformations in the coordinate plane. So a matrix is a new thing for us and something that you will be using in your higher level math courses. So first of all, we need to know what is a matrix. So I've highlighted in green the definition of what it is. A matrix is simply a rectangular array, and that just is a fancy way of saying arrangement, of rows and columns used to organize data. The plural of the word is matrices, and matrices are used for a lot of purposes, but in this exploring, we're going to be using them to represent our pre-images and our images that are in the coordinate plane. So here is a triangle in the coordinate plane, and here is the correct matrix for that triangle. And I want you to see where these numbers come from. So first of all, I hope you can see from the ordered pairs for each point that these numbers in the top row are the x's of each one of these points. Now, we have 4 x's and we only have 3 points. So we'll talk about what happened here in just a minute why we got 4. The bottom row is the y-coordinates of each point. And again, we have 4 of them, even though we have 3 points. So that means this first column is point A, the second column is point B, and the third column is point C. Well, as you can see, this fourth column is a repeat of point A. And the reason for that is you can think about a matrix telling you how to draw the triangle. So you would start with point A, you would connect it to point B, and then connect at point C. But if I stopped there, I wouldn't have a triangle. I have to go back to point A to finish drawing the triangle. So that's why point A is repeated in this last column, because this is telling us how to draw the triangle. Start with A, connect to B, connect to C, and go back to point A, and that closes your polygon. So let's look at number 1 in our notes. If I want to fill in this coordinate matrix for the rectangle that is RECT and start at point R, it has started for us. It has the coordinates of point R, -2, -1. The -2 is in the top row and -1, the y-coordinates, in the bottom row. So if we are going to go in the order of the naming RECT, our next point that we will put in is point E. Well, I can see the coordinates of point E are 4, -1. So when I put that into my matrix, I'm going to put the 4 on the top row and the -1 on the bottom row. That column, though, represents point E. So then I would go to point C. Point C is at the point 4, 3. And so the 4 would go in the top row and the 3 in the bottom row. And then we continue to T, whose coordinates are -2, 3. So I would write the -2 in the top row and the 3 in the bottom row. And remember, if I was drawing this, I would start at R, go to E, then C, then T. I wouldn't have my rectangle yet. I have to connect back to R. So the R coordinates of -2, -1 are the very last column of my matrix. Let's look at number 2 on your notes. It says triangle CAR, or triangle CAR, is defined by this matrix. And so if I see 4 columns, that alerts me to the fact that obviously this only has 3 points. And we know that because it's a triangle, that it only has 3 points. It says the first column represents the vertex C. So what are the coordinates of C, A, and R in this triangle? So vertex C, it says, is the first column. So these are the coordinates of C. And when you write the coordinates, we write them as an ordered pair in parentheses. So C is the point 2, 1. Always remember the parentheses when you're saying it's a point. Otherwise, it just looks like a series of numbers if you just put 2, 1. So you always put ordered pairs in parentheses. Vertex A would be the next column. So its coordinates would be -3, 5, again in parentheses. And vertex R would be the third column, -5, -2. So remember that final column is just a repeat of vertex C closing up the triangle. So on our grid down here, we're just going to use those coordinates to actually graph that triangle. So we're going to go to 2, 1. I'm going to move this so I have a little bit of room. Sorry, guys. So 2, 1 is vertex C. So 2, 1. And I'm going to label that with capital C. -3, 5 gives me vertex A. And -5, -2 gives me vertex R. So remember, this is a triangle, so I wouldn't just leave these random 3 points there. I would actually connect them with a straight edge. So you can use the edge of your compass or your protractor as a straight edge and connect these points. And there is triangle CAR. So again, the matrix starts with point C and then goes to A and then R and then closes it up with C repeated again. All right, let's look at number 4 on your notes. It says starting at point F, what is the coordinate matrix for flags? So flags has 1, 2, 3, 4, 5 points, but remember that means that it's going to have 6 columns. 5 points means one more column than that is 6. So it tells us to start with point F. So F is the point 2, 1. So you remember the 2 is going to go in the first row and the 1 in the bottom one. So the first column represents point F. So it's called flags. So we would go to point L next. It's the point 2, 3. The 2 would go in the top row, the 3 in the bottom row. Flags, so A is next. A is the point 5, 3. 5 in the top, 3 in the bottom. Then G, 5, 5. 5 in the top, 5 in the bottom. S is 2, 5. So 2 and then 5. Now if I was drawing this, so far I have F to L, L to A to G, G to S. So to complete the flag, would I have to go all the way down to F? No, I just need to close it by going to L. So this time L is the repeat. It's the repeated in the last column because that is what completes the drawing of flags. Okay, so again, it's how you're drawing it. So F to L, L to A to G, G to S, S to L. So we close with L. And again, we have 6 columns because we had 5 points. So number 5 says, what is the coordinate matrix for the image F prime, L prime, A prime, G prime, S prime after a reflection across the y-axis? So if we were going to take this flag and reflect it across the y-axis, we would flip it this direction. That's a left to right flip. So which coordinate affects the left to right movement of points? The x-coordinate does. And so remember, if you're reflecting across the y-axis, you're changing the sign on your x. So where are our x's in the coordinate matrix? They are this top row. So this entire top row will change signs in this new coordinate matrix for that reflection. So instead of the point 2, 1, we have -2, 1. Instead of 2, 3, it's -2, 3. Instead of 5, 3, -5, 3. Instead of 5, 5, -5, 5. Instead of 2, 5, -2, 5. And instead of 2, 3, -2, 3. So all we did was change the signs on the entire top row because we were reflecting across the y-axis, and we know that that changes the sign on x. Let me get my lights back on. Okay, on number 6, we're just going to sketch that new image of flags after the reflection across the y-axis. Remember, we use prime notation for the image, so we're going to graph the point -2, 1, -2, 1, and that's my F prime. And then -2, 3 is the L prime. And then we have -5, 3, which is my A prime. We have -5, 5, which is G prime. -2, 5, which is S prime. And then remember, -2, 3 is just going back to L. So I can connect these, F to L, L to A to G, G to S, S to L. And if you were doing this for an assignment, of course use a straight edge, but just for the sake of time, I just drew those. So this is our original flag flipped over, or reflected is the correct terminology, across the y-axis to create our image. Okay, so let's look at number 7. Number 7 asks us to look at the new matrix, and it's an image of our original flags. And so just to have them a little bit closer here, I drew those original coordinate matrix of flags so we could bring it down here and see it a little bit better. So it's giving us an image in a coordinate matrix, and we have to determine what transformation occurred. So this was our original flag's coordinate matrix, and here is the image. So let's look at see what changed. Notice the top row did not change, but the bottom row did. And what changed on the bottom row? Just its sign. So what does the bottom row represent? Remember, those are our y coordinates. So if we simply change the sign on y, where did we move that figure? So remember, if you reflect over the y-axis, you change the sign on x, like we did in number 5. But this is changing the sign on y, so we must have reflected across the x-axis. So this is a reflection across the x-axis, because it changed the sign on y. Okay, again, we're going back to our original flag's coordinate matrix and comparing it to the image. And we can see in each row, the numbers have been switched. So 2, 1 became 1, 2, 2, 3 became 3, 2, and so on. So which one of these reflections changes the x and y coordinates position? Remember, that's a reflection across the line, y equals x. Reflection across y equals x. So reflection across the x-axis changes the sign on y. Reflection across the y-axis changes the sign on x. And reflection across y equals x switches the position of your x and y coordinate. Okay, so let's look at writing these rules as a coordinate matrix. So we already know how to write all these reflection rules in an ordered pair rule or in coordinate notation, but here is how those same rules are written as a matrix. So the reflection across the y-axis, you're starting with a point xy, but we're not putting it in parentheses like a point. We're writing it as a matrix. So remember, the x is in the top row and the y is in the bottom, and we have it in a bracket, not parentheses. And we're mapping those to new points in the matrix form where the sign on x has changed. So remember, that's the opposite of x, but y stays the same. Reflection across the x-axis, remember that changes the sign on y. So we start with our generic point xy in matrix form and map it to new points by changing the sign on y, so opposite y. And then reflection across the line y equals x, we have our original point xy, and it's being mapped to new ones where the y and x switch positions. Now, if you look at the drawings here, I want you to notice that up here, when we reflect across the line y equals x, do you see how the pre-image and the image overlap each other? And that's because the original flags crossed that line of y equals x. So that's what caused that overlap up there. Okay? So these in matrix form should look just like our ordered pair rules that we've been studying. It's just instead of writing them as points in parentheses, we're writing them as matrices inside these brackets. All right, so we're going to look at an animation here to learn another transformation, but I will do that on the next video.